Okay, so for the first question of independent is the IV is two different group, which is athlete and non-athletes, and the DV is BMI, which is numerical. Observation is independent because two different groups. Normality is normal, p-value is more than 0.5. Later we're gonna check the normality, and test to analyze is independent t-test. Okay, so the next step is to analyze the normality of data. We go to analyze, descriptive statistic, and then we go to explore, BMI, dependence, status, go to factor list, plots, normality, and continue, and click OK. Okay, so the test of normality. So the athlete is 0.09, the p-value is 0.092, and the non-athletes is 0.601. Okay, so the both p-value of athletes and non-athlete is more than 0.05, so it is normal. Okay, so next we need to analyze the independent t-test. Okay, first we go to analyze, and then compare means, go to independent sample t-test. So the test variable, BMI, status, grouping variable, define group 1, 2, then continue. Okay, so this is the independent sample t-test. Okay, first see the equal variance assume. Okay, so the significance is 0.756, so it is more than 0.05. So we need to look at the upper table. Okay, and then the p-value is 0.000. Okay, so the p-value is less than 0.05, so there is significant difference and not normal. Okay, so the p-value is equal to 0.000 and the alpha is 0.05. If the p-value is less than 0.05, so reject null hypothesis. If p-value is more than 0.05, and fail to reject the null hypothesis. So the results show that the p-value is less than 0.05, so we are able to reject the null hypothesis. There is significant difference between BMI, and there is significant difference of BMI between athlete and non-athletes. Okay, so based on the second question, the IV is two different groups, which is lean and obese women, and the DV is numerical, which is 24 hours of energy expenditure. Okay, so the next step is we need to analyze the normality of the data, which is we go to the analyze, descriptive statistic, explore, and then energy expenditure is dependent, status factor, plot, and normality, plot the test, continue. Okay, so the energy expenditure for lean women, the p-value is 0.048, which is not normal, and the obese women, the p-value is 0.143, which is normal. Okay, so since the lean woman p-value is not normal, let's see the skewness and kurtosis, which the skewness for lean women is 1.161, which is not normal because it is more than 0. So next we need to proceed to the non-para because the data is not normal. First we go to analyze, and then we go to non-parametric test, legacy dialogues, and then two independent samples. Okay, so test variable is status, define group 1, 2, continue man Whitney U. Okay, then okay. Okay, so based on the man Whitney test, the p-value is 0.002, which is the p-value is less than 0.05. So there is significant difference. Okay, so based on the result, the p-value is 0.002 and the alpha is 0.05. So if the p-value is less than 0.05, then we can reject the null hypothesis. If the p-value is more than 0.05, then it's failed to reject null hypothesis. So the result shown that the p-value is less than 0.05. So we are able to reject the null hypothesis. So there is significant difference of 24 hours of energy expenditure between lean and obese women. Okay, so the third question is PET test, where the IV is two group, which is pre-menstrual and post-menstrual. Okay, so the DV is numerical, which is the daily energy intake. Observation is dependent because using the same sample in two different conditions. Test to analyze is using PET test. Okay, first we need to analyze the differences between post-menstrual and pre-menstrual. Go to transform, compute variable, type difference. Okay, so post-menstrual minus pre-menstrual. So click OK. Okay, so this is the differences between premenstrual and postmenstrual. So next we need to analyze the normality data. We go to analyze, descriptive statistic, explore, and then put difference. And there is no factor list because there is only one group. Plots, normality plot with test, continue. Okay. Okay, so the normality is the difference of post-menstrual and premenstrual is the p-value is 0.490, where the p-value is more than 0.05, so it is normal. So next, we need to analyze the PET test, where we go to analyze, compare means, PET sample t-test, menstrual. Okay, so this is the PET sample t-test, where the premenstrual and postmenstrual p-value is equal to 0.000. So the p-value is less than 0.05, so there is significant difference and can reject the null hypothesis. So the p-value is equal to 0.000 and the alpha is 0.05. If the p-value is less than 0.05, so can reject the null hypothesis. If the p-value is more than 0.05, so it's failed to reject the hypothesis now. So the results show that p-value is less than 0.05, so able to reject null hypothesis. There is significant difference of the mean daily energy intake for premenstrual and postmenstrual. Okay, so the last question is PET test. So the IV is two group, which is pre-BMI and post-BMI. The DV is numerical, which is the BMI. Observation is dependent because using the same sample and two different conditions. Test to analyze is PET test. So first we need to analyze the differences of pre-BMI and post-BMI. Go to transform, compute variable, difference. Okay, so first BMI minus pre-BMI. Okay, so here is the differences between post BMI and pre BMI. So next we need to analyze the normality of the data. We go to descriptive statistics, explore. So put not no factor list because there is only one group. Okay, so the normality is the differences of pre and post BMI. The p-value is equal to 0.061, which is more than 0.05, so it is normal. Okay, next we need to analyze the PET test. So we go to analyze, compare means, PET sample t-test, pre-variable 1, post BMI variable 2. Okay. Okay, so from the table shown, the pre-BMI and post-BMI p-value is equal to 0.000, where the p-value is less than 0.05. So there is significant difference and able to reject null hypothesis. So from here, the p-value is 0.000 and the significant level is 0.05. So if the p-value is less than 0.05, so we're able to reject null hypothesis. If p-value is more than 0.05, so we fail to reject null hypothesis. So from the result shows that the p-value is less than 0.05, so able to reject null hypothesis. Conclusion is there is significant difference of BMI between before and after BMI intervention.